In this video series, we are going to be working with the general form of quadratic equations and transformations with it. And so this video is going to focus primarily on what is general form and how to identify all the parts of a quadratic from the general form. Now you'll also see that general form is referred to as vertex form. And the reason why it's also referred to as vertex form is because written in this form, y equals a times the quantity x minus h squared plus k. By writing it in this general form, it's easy for us to identify our vertex. The vertex is your h value and your k value. So your vertex is the coordinate of hk. Your axis of symmetry, remember, is the x value of the vertex. So my axis of symmetry is x equals h. And when we dealt with transformations before, we learned that if your leading coefficient is positive, the graph is opening upwards. If your leading coefficient is negative, the graph is opening downwards. Now, the key here, and the place where most students make their errors, is with identifying the h value. The formula says x minus h. And so we're going to find out the problem occurs with students with identifying the h because since the formula has a minus sign, the h value is going to be the opposite of what you see. And so if we take a look at example A, now I have it all worked out for us as a graph. We're just going to fill in some of the information based off of what our general form says. We have y equals 2 times the quantity x minus 4 squared plus 3. So my a is 2. The easy one, my k is 3. The hard one is the h. The h, the form says x minus h. So you have to look at what number are you subtracting, and I am subtracting just 4. So my h is 4. So that means my vertex is the coordinate hk, so it's the coordinate 4, 3. My axis of symmetry is x equals your h value, which is 4. My a value is positive 2, so that means my graph would be opening upwards. And so we can take a look, and I'm just focusing on this left side of the screen. I used all of my a, h, and k values with the general setup. Your vertex is going to be hk, 4, 3. Your axis of symmetry is going to be x equals h, x equals 4. If a is positive, the graph is opening upwards. A was 2. So if I take a look, I have my vertex, I have my dashed line to represent my axis of symmetry, and my graph is opening upwards. And so that's how we use our general form, our vertex form for a quadratic. So let's look at another example. Same idea, same information about your vertex is hk, your axis of symmetry is x equals h, and when your graph will open up or down. And we have our general form. So I'm going to bring that down here above my example B so I can use it with identifying the parts in this problem. And yes, you have the graph on the screen. Just ignore the graph. Focus on the left side of the screen so you can see it start to resemble the graph. And so identify all your parts first. A is negative 2. I go right to K next because it's easy. K is negative 2. H involves some thinking. The formula says x minus h, but your problem says x plus 1. And so you need to figure out, what number are you subtracting in order to make it a positive 1, and you're subtracting a negative 1. So h is negative 1. So your vertex is the coordinate hk, which means your vertex is the coordinate negative 1, negative 2. Your axis of symmetry is the equation x equals h. You have to include the x equals. So x equals negative 1. The direction of the graph, if a is positive, it's opening up. If a is negative, less than 0, it's going to be opening down. And since a is negative 2, the graph is opening down. So now I have all my information about the graph just from having it in my vertex form. And you could take a look. Your axis symmetry is x equals -1. The vertex is -1, -2. The graph is opening downwards. By having it in this form, I can see all this information very easily without doing, after it's in this form, without graphing it, I can see, hey, my vertex is -1, -2. It's opening downwards. My axis symmetry is x equals -1. And now we can compare it to the graph. So be confident, be familiar with your general form, your vertex form. Understand, and maybe you want to make a note, the h value is always opposite of what you see in the parentheses. And the reason why it's opposite of what you see is because the vertex form has x minus h, the opposite of h. So the opposite of what you see is your h value. That's the tricky part. So just be confident with that vertex form before you move on to the rest of the videos.